Good morning to everyone. We are from Group 5, Section 1, for the subject code is BBP10603, Mathematics 1 course. Our project is titled is a Trigonometry in Action, Real World Measurement Around Campus. The code of our project is Trigonometry, a, a vital brand of mathematics with one application in the real world, such as architecture and engineering. Through this hand-on activity, we successfully bridge the gap between theoretical knowledge and practical implementation, fostering a deeper understanding of this mathematical concept. Now, I want to hand over to Atika for objective project. Next slide.
For objective, first, our project aims to apply mathematical concepts, specifically angle of elevation and depression, as well as trigonometric ratios, to measure different structures around the campus. Second, we will analyze the data we collect. This includes assessing how accurate the trigonometric method is and understanding its limitations. Lastly, this project helps us collaborate as a team. Each member will contribute through assigned roles, data collection, analysis, and presenting our findings.
Assalamualaikum, my name is Putra Danish bin Muhammad Salim, and today I will answering question number 1, which is how to find the height of a flagpole. Based on our data table, we managed to get 3. First is 1.6 meter, which is observer height. The second one is the distance from the flagpole to the observer, which is 4.8 meter. And the third one is the angle of the clinometer angle, which is 45 degree. For the formula is height equals d tangent plus observer height. For the calculation, the first one is we need to insert the value into the formula, which is height equals 4.8 multiplied tangent 45 degree plus 1.6. For the first step to calculate is we need to calculate the tangent 45 degree by using a calculator. For the answer is going to be 1. So the equation becomes height equals 4.8 multiplied 1 plus 1.6. The next step is we need to perform the multiplication, which is 4.8 multiplied 1, we get 4.8. After that, we need to add the observer height, which is height equal 4.8 plus 1.6. So the final answer, the height of the flagpole is going to be 6.4 meter. Thank you.
Thank you, Putra. We now move to second question, which is calculating the slope angle of the staircase. Our objective is to determine if the staircase slope on our campus meet the accessibility standard. Based on the data we collected, first one is rise, 56 mm, and then the sun is 300 mm. Okay, to calculate the slope angle, we use the trigonometry ratio tangent. The formula is tangent equal rise over sun. Let's insert the measured value into the formula. Tangent equal 56 over 300. The answer is 0.1867. To find the angle, we use the inverse tangent function or ART tangent. We go to the formula tangent power negative 1 bracket 0.1867. So the answer for degree is 10.57 degrees. So for the angle tile is normal.
So for question number 3, which is the river, road or courtyard, 2-point observation. So we choose lake for the calculation. So based on our information on the data table, which is we get to calculate the distance between the two observation points, which is t. So the distance between the two observation points is 160 feet. Okay. Number 3 is angle measured at the first observation point, which is A, and we get 26 degrees. And number 4, angle measured at the second observation point, which is B, is 64 degrees. So for the calculation step is number 1, calculate the tangent using the calculator. So you got calculator here. So all you need to do is tan bracket 64 equals, and then you will get the tangent for point B, which is 2.0503. Next one is the tangent for point A. So just put tan bracket 26. So we get 0.4877. Insert the information into the formula. So using the formula, use 116 and tan A, which is 0.4877, and then below with tangent B, which is 2.0503, and then divide to tan B, 2.0503, deduct 0.4877, which is tan A. So for step number 3 is multiply the tangent given, which is tangent A and tangent B. So 0.4877 multiply to 2.0503. So you will get 0.99. So it will be 1.0. And next one is multiply the distance between the two observation points D with the tangent. So it will be 116 multiply to 1.0, and then it will be 160. For step number 4, which is subtract the tangent, so you need to deduct both of the tangent, which is 2.0503 deduct to 0.4877. So the width is 74.24 feet, or if you want to convert it to meter, it will be 22.6.
Today, I will explain how we measure the height of a straight line using simple method called the shadow method. This method is useful when the object is too tall to measure directly. The idea behind this method is straightforward. When two objects stand under the same sunlight, their shadow grows in proportion to their heights. This means the ratio between height and shadow length stay consistent. So by using something we already know, we can calculate something we do not know. Here are the measurements we use. The person height 162 centimeters, the person shadow length 151 centimeters, the straight line shadow length 452 centimeters, and the height of the straight line is what we want to find. This slide shows the proportional formula used in the shadow method because both the person and the straight line are under the same sunlight. Their height to shadow ratios are equal. We compare the person height and shadow, which we already know, with the straight line shadow. Using this ratio, allow us to calculate the height of the straight line. Okay, step-by-step calculation. First, we find the ratio of the person height to their shadow. We take 162 centimeters and divide it by 151 centimeters. This gives a value of about 1.07285. This value tells us how many times taller the person is compared to their shadow. Next, we apply the same ratio to the straight line shadow. We multiply 452 centimeters by the ratio. This gives an estimate height of about 484.93 centimeters. From our calculation, the straight line is about 484.93 centimeters tall. If we convert that into meters, it becomes roughly 4.85 meters. This height makes sense for a small to medium-sized street lights. This method works only if certain conditions are met. 1. The ground must be flat. 2. Both objects must be measured at the same time under the same sunlight. 3. Shadow length must be measured accurately from the base to the tip. Even small mistake in measuring the shadow can change the final result. In conclusion, the shadow method is a practical and effective way to estimate the height of tall outdoor objects. By using simple measurements and proportional reasoning, we calculate the streetlight height to be around 4.85 meters. That's all from me.
Okay, for question 5, angle of hill or slope in column topographic study, we can see that we need to find the vertical change, horizontal distance for find the slope angle, and the formula used is tan equal to vertical change per horizontal distance. Okay, we can see that vertical change we found that it's 5.9 feet, and for horizontal distance it's 16 feet. So in calculation, insert value in the formula tan equal to 5.9 per 16.0 and calculate the ratio, and we find that tan equal to 0.36875. And how to find the angle using the inverse tangent function, tan minus 1 in column 0.36875, and we found that the angle of slope angle is 20.24 degrees.
For the error analysis, first is basic tool limitation. Our homemade clinometer and the standard measuring tool quite lack of the precision of professional equipment. The second one is the environment. We face uneven ground, irregular stair dimension, and the changing of sunlight. The third one is the human measurement challenge. It's quite difficult to perfectly align our sight and to keep the tool perfectly level. And the fourth one is the imperfect method assumption. Every trigonometric method we use relies on ideal geometric shapes and conditions, which only approximations of messy and complex of the real world. Thank you.
For the conclusion, the project successfully the practical application of trigonometry in solving real-world measurement problem. Secondly, successful example including calculating the height of flagpole and determine staircase slope or weakness. The last one, mathematical understanding was trained at anxiety scale like teamwork, critical analysis, and communication. It was development in this project.
Our recommendation after we have done this project, number one is data accuracy, which is we need to utilize more precise digital instrument and conduct repeated measurement to minimize the error. Next one is verification, which is we need to get more integrated technology, which is simulation software or apps for visualizing and verify result. This means that we could get a better result for the calculation.